This is problem number 2 on the practice problems for quest number 4. Solve each of the following quadratic equations. A, negative 2x squared plus 15 equals 3x squared. So oftentimes with quadratic equations, you want to get one side equal to 0. But in this case, I don't know if you noticed, but there's no term with just x. A lot of times the problems that we solve have this form. But there's no term with just an x here. There's an x squared term, there's a constant term, but then there's another x squared term. So that's our giveaway that actually what we want to do is group the x squareds together. So we're going to add 2x squared to both sides. And then we'll get this equation. And hopefully you recognize that there's an easy way to solve this equation without getting into any of the factoring or any other methods that we have for solving quadratic equations. And that's to just isolate the x squared by dividing both sides by 5. And then finally, take the square root of both sides. I'll put x squared equals 3, and then I'll stick in the square root symbol in another color. And then we're just about done here. Square root of 3 is that. Square root of x squared is x. Not quite. It's actually the absolute value of x. And this is one of those instances where we need the absolute value because there's actually two answers to this question. Not just the square root of 3, but also the negative square root of 3. There's our answer. And if you leave off that negative, then you're not going to get full credit. It's not right. The original equation, this one here, has two different answers. Square root of 3 works, but negative square root of 3 works just as well. And so there's a big difference between, for example, me saying, can you solve this equation versus, can you tell me what the square root of 9 is? The square root of 9 is plain old 3. But this equation has two answers, plus or minus 3. And it's the act of taking the square root that introduces that plus or minus. Part B, 3x squared equals 2x. Same idea as before. We are missing a term, but this time we're missing the constant term. So here we are going to want to get one side to 0. So we'll subtract the 2x. So we get 0. And then you're going to want to factor. You're going to factor out something. Factor out the greatest common divisor of all these terms. What comes out of both terms is an x. So what's left in the parentheses? 3x minus 2. And I just want to point out that anytime that constant term is missing, you're going to be able to factor an x out because there won't be any term sitting there by itself that won't have an x in it. Okay, and now we get to use our friend the zero product property. So we're splitting this up. Either x is equal to 0 or 3x minus 2 is 0. Okay, x equals 0 is done. Over on this side, you're going to add 2 and then divide by 3. So we get our two answers to this one, 2/3 and 0. And I'll just point out one other way there is to go wrong on this problem. It's very tempting in this case to cancel one of these x's. Divide both sides by x. So if we divide here by x and here by x, it seems legitimate. And on the left-hand side, you just get 3x. And on the right-hand side, you just get 2. And divide both sides, and we get x is 2/3, which is one of our answers. But the problem is we lost the other one. We lost x equals 0. Why did we lose it? Well, dividing both sides by 0 is perfectly okay as long as dividing both sides by x is okay as long as x isn't 0. But you're not allowed to divide both sides by 0. And it turns out that was one possible solution, and we lost it. So we're going to get rid of all that stuff and strongly, strongly, strongly encourage you to not divide both sides by x or anything with a variable in it, but rather get one side to 0 and factor. Then you won't lose that solution. Part C, 2x plus 7 times x minus 8 equals 0. A lot of folks feel an obligation to start distributing here. Nothing wrong with that, except it's getting you further from the answer. It's already in factored form in Part C. You're not obligated to FOIL every time you see something that is FOILable. So in this case, foiling goes the wrong way. It's legal, but it's a bad idea. We're ready to split this up. Either 2x plus 7 is 0 or x minus 8 is 0. So don't FOIL just because there's things that you can FOIL. So subtract 7 and divide by 2. Add 8. And we have our two answers. Don't take an easy problem and make it hard by foiling. Part D. X squared plus 3x minus 4 equals 6. Can't have it equal 6. This is a full-on quadratic with all three terms, but we need one side to equal 0. So let's bring that 6 over to this side by subtracting it. And now we're going to try to factor, because if we can factor this thing, then it's going to look an awful lot like part C. Once it's factored, we can use that zero product property. So pause the video, take a moment, see if you can factor. This is the place where we're thinking about products and sums. Product is supposed to be, grab that sign, -10. Sum is supposed to be +3. So pause the video, see if you can find those two numbers. And if you're back, hopefully you get the same two numbers I do, +5 -2. It's okay in the other order. And then we're ready to split it just like we did before. Either x plus 5 is 0 or x minus 2 is 0. Solve each of these easier equations for x. And we have our two answers. Part E. 3x squared minus 75 equals 0. Okay, a couple of ways to do this one. For me, I'm thinking that this looks quite similar to part A, where there was the bx term was missing. So for me, I'm going to move the 75 over to try to isolate the x squared. Divide both sides by 3. We get x squared is 25. And then we're ready to do our square root of both sides. We'll put it in a different color. This is the place where it's really easy to go wrong and say, okay, x is 5 and I'm done. Because the square root of x squared isn't x, it's absolute value x. So we have two answers here, not just 5, but -5. That's one option. Your other option, or I'll rewrite the original. You can start factoring just as it is. It's equal to 0. Let's get rid of this. It looks like a minus sign. So it's equal to 0. So we're ready to start factoring. You can factor something out of both terms. What is it? It's the greatest common factor or the greatest common divisor. It's 3. And then this thing in the parentheses hopefully looks quite familiar to you. It is the difference of squares. It's got its own fancy little formula. This was the thing in class that was a plus b times a minus b. In this case, x minus 5, x plus 5. Split it right down the middle. And either x minus 5 is 0 or x plus 5 is 0. Solve for x, and we get x is 5, x is -5. If you do it this way, you don't have to worry about remembering the plus or minus. It's right there. When you do that difference of squares formula, both signs come out. And one little detail, here's a multiplication, here's another multiplication, but it seems like the 3 got shortchanged because everybody else got equal to 0, right? X minus 5 is 0, x plus 5 is 0. What about the 3? Well, you're perfectly welcome to try to solve that equation when 3 is equal to 0, but it never is. So oftentimes people don't even write it. We just get our x equations and ignore the constant sitting in the front. Moving on to part F, x squared plus 1 is equal to 0. Again, we're missing that x term, so I'm ready to isolate the x squared. So let's subtract 1 from both sides. And then take the square root of both sides. I'll recopy it here, and then we'll put the square root symbol in a different color. Okay, we've done this a few times in this video. Square root of x squared isn't just x. It's absolute value x. Square root of -1, recently, we would just stop there and say it's not a real number, which is true. But we've expanded our number horizons, so square root of -1 now has a name. It is I. And then finally, how do we handle that absolute value? We just stick a plus or minus on the other side. So plus or minus I is the answer. And then finally, part G. Negative 12x squared plus 31x minus 20 equals 0. Okay, first, I'm not thrilled that there's a negative in front of the x squared. I'm really not thrilled that there's a 12 in front of the x squared, but what I can handle is that negative sign. So how about we move everybody over to the other side by adding and subtracting. So add the 12x squared to both sides, subtract 31x from both sides, add the 20. Not saying it's a lot better, but at least the x squared term is now positive. Okay, so how do we handle something like this? Well, it's going to be kind of a mess. You're welcome to do some trial and error, but I think that there are going to be a lot of trials and a lot of errors before you finally hone in on the right answer. You're also welcome to use the method that the book uses. It involves a rectangle or a square or a box. I'm going to do the thing that I've been calling funky factoring, so let's give that a shot. So step one for funky factoring was to multiply, well, I guess physically pick up this number right here and jam it into there by multiplying it. So x squared minus 31x plus 240. And then we're going to factor this thing. We'll keep the 0. So we're going to factor this thing. It's still hard because 240 is a big number and it's got a lot of factors, but we can at least write down the product sum thing because now it's not, there's just a 1 sitting in front of there. And so we can handle it with this product sum idea. So we want two numbers whose product is, grab the sign, 240, and whose sum is negative 31. Okay, so how are we going to do it when we have an enormous number like 240 and we don't necessarily just know all the factors off the top of our head? Well, the calculator can help. So we're looking for numbers that multiply to give me 240. All right, so clearly 240 is divisible by 2. So how about we just figure out what that's equal to? So it's 120. So I'm just going to make a list here. We're not going to list them all, but we'll start making this table anyway because the 240 is so big, and I just want to give you the thought process and how you can use your calculator to help. So we did 2 went into it, and it went in 120 times, and if you add them, it's 122. And I'm looking for 31. I guess I can do a negative 31 by just putting negatives in front of everybody. So back to the calculator. 120, is it divisible by 3? Yes, it's equal to 40. So we could have done 3 and 40, or we'll stick negative signs, and we get negative 43. And guess what? That's a lot closer to the negative 31 that we're after. So maybe we're not too far away from getting our answer. So we did 2, we did 3. Let's keep going. We'll try 4. Is 240 divisible by 4? It is. It's 60. Something is funny here. 3 times 40 is not right. I'm sure you guys caught that well before I did. So try that again. 240 divided by 3 is 80. Okay, so that's negative 80 and that's negative 83. Not nearly as close to the negative 31 as we were hoping for, but let's just keep going down the line. 240 divided by now 4 is 60. So we could do 4 and 60 with negatives on both. And that's negative 64. And you can see these numbers are creeping towards our ultimate goal, the negative 31. So this is a methodical process. I'm not saying it's the quickest process, but it'll get us there. And it's a process that you can just follow. Okay, next one, 240. Is it divisible by 5? You bet, 48. So we could do 5 and 48. I'm not going to write the sums. I'm not even going to write the negatives. I just want to keep doing this until we get something good. 240 divided by 6. Try again. 240 divided by 6 is 40. Okay, we're getting there. 240 divided by 7. That's a mess. Okay, it's clearly not that one. 240 divided by 8. That's getting really close now. 240 divided by 9. That doesn't go in. 240 divided by 10. That's getting really close. I'm going to write that one. And some of these you might just be able to do in your head, but again, I was hoping to give you a process. So right now, we're here, and that's a negative 34, which is so close to our negative 31. Okay, next one. Is 240 divisible by 11? No, it's 240 divisible by 12. Yes, it's 20. Let's write that. So we just got 12 and 20. Negatives in front of both, that's a negative 32. That's really close. Okay, so we were at 12, so we do 240 divided by 13. That's probably not going to go in. 240 divided by 14. Nothing there. 240 divided by 15. 16. 15 and 16. Negatives in front of both give us our desired 31. Like I said, it's not the quickest process in the world, but it is a step-by-step methodical thing that you can follow to take any big factor, any big number that you don't know the factors of, and whittle it down to size. And in fact, you didn't need to go as slowly as we did here. With a little bit of practice, you start to acknowledge that, like these numbers are just so, well, one of them is so big that there's no chance it's going to give you something small like negative 31. And so you skip some of the small divisions. And you don't do 2 or 3 or 4 or 5, you just skip right to 10. And then you can kind of shorten it up. But that comes with practice, and this is at least a step-by-step process to follow. And with all that work, you might think we're done, but we're not there yet. So negative 15 and negative 16 were our two factors. So that means that this equation right here is the same as, so x and x, and we just found the factors down below are negative 15 and negative 16. So should we solve this for x and get our two answers of 15 and 16? And the answer is no. We've been doing funky factoring here and we haven't finished it. So remember, the first step for funky factoring was taking that 12 and jamming it into the 20. Well, the 12 doesn't just disappear. We got to bring it back. So now we'll bring it back in both places. So I'm going to copy what we had. X, X, and then we'll put the 15 and 16 back. But now the 12 comes back, returns in front of both of these guys. And then this is the real funky part, where we divide each parentheses by its greatest common factor. So what number goes into 12 and 15? 3 goes into both. What goes into 12 and 16? 4 goes into both. And then I think we're just about done. So when we take that 3 and divide it into the 12, it gives me 4. 3 into the 15 is 5, so we get 4x minus 5. Next parentheses, 4 into 12 goes 3. 4 into 16 goes 4. And after all is said and done, this is the correct factorization for the original problem. Well, maybe not quite the original problem. Our version where we got the x squared to be positive. Okay, so now we've got our factors. It's equal to 0. We just need to finish. So we'll split this up using the zero product property. Either the first factor is 0 or the second is 0. Add 5 and divide by 4. Add 4 and divide by 3. And after all that, we finally have our two answers of 4/3 and 5/4. Now, if you happen to know the quadratic formula, then that might be the way to go. I was pretty intimidated from the beginning looking at this original guy, because the 12 has a lot of factors, 20 has a lot of factors, there's pluses, there's minuses. It's a lot of work no matter how you do it to try to factor this one. So maybe instead of doing any of that work, if you have the tool that is the quadratic formula, you could just go for it right from the beginning. Don't even worry about making the 12 positive. Just use the quadratic formula on the initial thing, and eventually with the quadratic formula, we'll get down to exactly what we had, 5/4 and 4/3.